Okay, so I'm going to do some off worksheet 5 today. The first thing I'm going to do is I'm going to go ahead and work both sides of this one. I know you don't have to. So secant is 1 over cosine. That's a beta, by the way. It's another Greek letter. My pen is acting weird. I don't know why, but it's jumping around a little bit. So I got minus, tangent is sine beta over cosine beta. Then we're going to come up here and we get this side. This secant is also 1 over cosine. I'm working both sides again, and then this is plus sine over cosine, changing everything on both sides to all sines and cosines. So over here on the right side, I notice I already have a common denominator, so I'm going to put both numerators over my common denominator. I'm going to have 1 plus sine beta all over cosine beta. On this side over here, I got common denominators in the bottom, so I'm going to put this as 1 over 1 minus sine beta over cosine beta, because the cosine is the same in both parts. And then I'm going to make this top one into a fraction by making a 1 over 1. So I got a fraction divided by a fraction on the left side. So I'm going to flip this bottom one upside down and multiply 1 by the reciprocal of this, which will just be the reciprocal. So this is cosine beta over 1 minus sine beta, which is supposed to equal 1 plus sine beta all over cosine beta. Now this is just like example I did in number 7 from worksheet 4. I'm going to cross multiply because I now have a proportion. So I'm going to have cosine squared beta over here when I take cos times cos. And over here on the right side, I'm foiling 2 conjugates, which is 1 minus sine squared beta, which this thing over here is cosine squared beta. And I am finished with number 8. That is a pretty hard problem. It's just like I told you, each time we go through another worksheet, they get a little harder. So let's go see what we can do on this side. Number 12, I think the right side is more complex, so I'm going to do the right side. I'm going to do it the fastest way possible. I see that these two have a sine squared in them, so I'm going to factor a sine squared out of both of these terms. And that will leave me 1 minus sine squared inside. I'm going to take that sine squared out on the other side of the cosine. So I factored this sine squared that I just wrote down right here. This sine squared I took out of both of these. And then 1 minus sine squared is cosine squared x. And then cosine squared times cosine is cosine cubed x. I've got sine squared x, which is exactly what I was supposed to get to show that both sides were equal. So that one I did one side. Number 13, I may work both sides on this one. So the first thing I'm going to do is change both of these into well, there's actually a couple ways I can do this. I think I'm going to split this up into 1. This can be written as 1 times 1 is still 1. So I can write this as 1 over cosecant times 1 over cotangent. And I'm going to do this side. I'm going to make this one 1 over cosine and minus cosine over 1. And do both of these. And I can see that they accidentally left off the theta. There's got to be a theta up here as well. Okay, so over here, I'm going to do the reciprocal of both these. So 1 over cosecant is sine theta. And the reciprocal of cotangent is tangent theta. here, I'm going to get a common denominator. Cosine and 1 are my two denominators. So that means cosine is my least common denominator. So I'm going to multiply this side by cosine theta over cosine theta, just this one right here. And I hope you see you get a cosine in the bottom. So that makes my common denominator over here a cosine. And in the top, I get 1 minus cosine squared theta. When I multiply these two, I get, let's see, cosine times cosine is cosine squared. So this over here in the top is sine squared theta over cosine theta. And then right here, I'm going to change that sine right there, or tangent, into sine over cosine. And then multiplying across the top, I get sine squared theta over cosine squared theta, or not cosine squared, it's just cosine on the bottom. And these two things are identical. And number 14 is the last one. This one's kind of hard, but not really if you know some secrets. And I'm going to do this the fast way because I don't really want to take a long time doing it. I'm going to change 4 into 3 plus 1. That's equal to 4, and then I got plus tangent squared. Now what this part does right here is this part is one of my Pythagorean identities, which is secant squared theta, or x. We're doing x's here. And then I'm actually supposed to flip-flop the order of either this one or that one because I got to show they're exactly the same. So commutative property says I can flip-flop the order of a plus sign, and that equals this side over here, and I am all done. Have a good day, and I will see you next time.